Assalamualaikum and hello everyone. I'm here to explain on the first topic in chapter 3. My name is Nur Siti Khadijah and I am from UiTM Johor. Okay, so the first thing in this chapter that you need to know is the introduction of proving. Okay, so introduction to proof. First is, what is proof? In mathematics, a statement is considered as a sentence or proposition that will be either true or false. I believe that this is what you have learned in chapter 2, which is you learn what is statement, what is not statement, and then you learn the statement is sentences or true sentences or false sentences. Okay, a proof itself is a convincing argument that can be expressed in the language of mathematics. So it's an argument. So, and then the first very step in doing proof is to identify the hypothesis A and the conclusion B. So this is the important part, which is you need to know what is the hypothesis and what is the conclusion in the question. Okay, so what is that? What is the hypothesis and the conclusion? In doing proof, trying to conclude the statement are true or false much more easier by writing the implication in the form of if A then B. So this is the implication form that you have learned in chapter 2, which is if the statement is using if then it will become this, right? A implies B. So in this case, if you want to prove, it is easier if the statement or the question or the proposition is written in this kind of form, which is if then. In case the implication are not written in those specific form, so there is a case that the question is not written in this form, so what you want to do? So you have to find the hypothesis and the conclusion from the sentences using the definition of the hypothesis and the conclusion itself. So what is hypothesis? Hypothesis is everything that you assume to be true, and the conclusion is the conclusion of the statement or statement itself that you need to be proved will be the conclusion. Okay, so the first thing is the hypothesis is something that you assume to be true, and the conclusion is something that or the statement that you need to prove. Okay, in case it is not written in this form, you have to know this. You have to find this. What is the hypothesis and what is the conclusion? So if it's written in the if then form, so it is easier. After if, before then is the statement A, and after then is the statement B. Okay. Let's see some example. So the first example is if n is an odd integer, then n square is an odd integer. So you notice that in this sentence, in this question, it used if then form, which is after if, before then will be the statement A, and after then will be the statement B. So basically this is the hypothesis and this is the conclusion that you need to prove. So the hypothesis will be n is an odd integer, and the conclusion will be n square is an odd integer. So this is the basic form that you will see in this chapter. So example number 2, what if it didn't write in the if then form? So let's see this question. This question say that let P be an odd integer and Q be an even integer. Prove that PQ is even. So you need to find the hypothesis and the conclusion. So from here you know that what you want to prove is this. You want to prove PQ is even. So if you want to prove that PQ is even, you need to find the P and the Q in the sentence. So what is P and Q? P be an odd integer and Q be an even integer. This statement you will assume to be true. Assume to be true. So what you assume to be true will be statement A, and what you want to prove will be statement B. Okay, so the hypothesis here is P be an odd integer and Q be an even integer. So the conclusion is PQ is even. Okay. So next we're going through the next method, the first method in this chapter, which is forward-backward method. So before that, you need to know the step in doing forward-backward method. So the first step in solving forward-backward method is recognizing what is the hypothesis and what is the conclusion, which is statement A and B. So if you have the question, this is what you have to do first. You need to find what is statement A and what is statement B. Okay, what is the hypothesis and what is the conclusion? Remember, A implies B, or the hypothesis and what you assume to be true and what you want to prove. Okay, so in proving A implies B, we must somehow assume that statement A is true. Okay, and use any formula or information related to reach the conclusion that is B is true. So basically, we have statement A, we have statement B from hypothesis and conclusion. So we will going to find B1, which is the conclusion, and we will going by formula or any statement, formula or information related to get the conclusion. Okay, so this is what forward-backward method going through. Okay, so what is backward and forward process? So backward process is when writing the proof to reach the conclusion that B is true. So like I write before, you need to writing the proof to reach the conclusion that B is true. Backward is the B process. We're going to B1. Okay, so forward process when deriving from the statement A, which assumed to be true, some other statement A1 that know to be true as a result of A being true. So from the statement hypothesis, we come out with A1, which is the statement that is true if A is true. So since we assume that A is true, so statement A1 that comes from A will be true. It should be emphasized that the statement derived from A are linked up with the last statement obtained in the backward process. So it will link up until you get the statement that derived from the backward process. So until you get B1 here. Okay, B1 or B, or any conclusion that you can make from statement backward process. Okay, so for example, given that if n is an odd integer, then n square is an odd integer, prove it by using the forward backward method. Your answer should have an analysis proof and the condensed proof. So analysis proof and the condensed proof. Here I will show you how to do the analysis proof and the condensed proof, but we must focus on the question itself. So this is the question: if n is an odd integer, then n square is an odd integer. So basically it is in the form of implication, A implies B. So after if, before then, this is the hypothesis, and after then is a conclusion. So remember that you need to use forward backward method and you need to write in analysis and condensed proof. Okay, next. Okay, so from here we have statement A is n is an odd integer, and B, statement B is n square is an odd integer. So from here, to solve this, we need a little definition. What definition should we have? Definition of odd number. So an integer n is odd if and only if n equal to 2k plus 1 for some integer k. This is the definition of odd number. In this form, n equal to 2k plus 1 for some integer k. If you put any integer in k, so n will be odd. So if k equal to 1, and it will equal to 3, if k equal to 0, n will equal to 1. So it follows until k is any integer. Okay, so let's move to our proving. So from the backward process, n square is an odd integer, and from the definition here said that an integer n is odd if and only if n is equal to 2k plus 1 for some integer k. So if we say that n square is odd, so n square will equal to 2k plus 1 for some integer k. Okay, so we stop in here for the backward process. Let's move to forward process. So this is basically the direction of our proof. We need to prove until here, until we get n square is equal to 2k plus 1. Okay, so let's see from the forward process. From statement hypothesis, n is an odd integer. So if n is an odd integer, n will equal to 2p plus 1 for some integer p. So basically this is from the definition. We change k into p. We do not use the same unknown from the backward process. Okay, so this is just to differentiate it, and it will not make you confused in the ending of the proving. Okay, so n will equal to 2p plus 1 for some integer p. This is from definition, and then from here, since we want to find n square, is it true that n square is equal to 2k plus 1? So from n equal to 2p plus 1, we find n square. So let's square. If we squaring the left hand side, we need to squaring the right hand side. So squaring the right hand side, expanding. So you get 4p square plus 4p plus 1, and by factorizing this, you got factor out 2. So you got 2p square plus 2p plus 1. Why we factorize 2? You need to remember what I said before, that this is our direction of proving. So we want to find 2k plus 1. So that's why we factorize 2 here. And then we get 2p square plus 2p plus 1. And this will equal to 2k plus 1 if k is equal to this. Okay, if we substitute this into k, let k equal to 2p square plus 2p. So we got 2k plus 1. So this is basically the ending of the proof, because we get n square equal to 2k plus 1, same as b1. That's why here we write it is equivalent to b1. So this is basically your analysis proof. And let's look at the condensed proof. Condensed proof is what you write from the analysis proof. So from the hypothesis, let me erase some here, right, to make you the view clear. Okay, so from the hypothesis, n is an odd integer. So from the A, basically, by the definition of odd integer, by the definition here, so n equal to 2p plus 1. Squaring the left hand side and the right hand side, this is the step here, squaring the left hand side and the right hand side. Of n equal to 2p plus 1, we will get n square equal to 4p square plus 4p plus 1. Factoring 2 from the right hand side, we will get 2p square plus 2p plus 1, and this will be equal to 2k plus 1, where k equal to 2p square plus 2p. This is from here. Thus n square equal to 2k plus 1 for some integer k, and n square is an odd integer. When you reach here, this is what you got from B1, and then this is what you get. This is the statement from B. So this is your condensed proof. You can write it in your own way for the condensed proof part and the analysis proof, right? So example number 2. Given that if the triangle RST is equilateral and SU is a perpendicular bisector of RT, so imagine that RST is the equilateral triangle, imagine, and SU, let's say RST, you can put this into either way of your drawing, doesn't matter. So because it's a equilateral, so it will be the same length. So, and SU is a perpendicular bisector of RT. SU, we need to write, make a line S to U, and this is the perpendicular bisector. Perpendicular bisector, which means these two will have the same length, RU equal to RT. Line RU will be equal to line RT. Then the area of triangle RST is equal to sub 3 RS square over 4. Prove it by using forward-backward method. Your answer should have an analysis of the proof and the condensed proof. So basically, this question is written in the form of implication, which is if-then form. Okay, where is the then? Here. Okay, so after if, before then will be the hypothesis, and after then will be the conclusion. So let's see how to solve this. Okay, so statement hypothesis, we have the triangle RST is equilateral and SU is a perpendicular bisector of RT. Basically, I have to draw this for you before in the previous slide. So this is the proper drawing of it, of the triangle. This is the equilateral triangle. Basically, it has the same length, and as you make a perpendicular bisector, so RU and UT will be the same length, in the same length. So the conclusion here is the area of triangle RST is equal to sub 3 RS square over 4. And we got B1. B1 is, we just take the RST is equal to sub 3 RS square over 4. So to make it simpler, but you can stay with B, doesn't matter if you don't want to get RST equal to sub 3 RS square over 4 as B1, you can stay in B. That's your proving and that's your way. So I am doing it like this. It becomes clearer if I write it like this. So from statement, from the hypothesis, we got the triangle RST is equilateral and SU is a perpendicular bisector of RT. So to make this word simpler, first we assume that RST is equilateral to be true, since equilateral, so it have the same length. So RT will be equal to RS will be equal to ST. So this is the equilateral triangle. Okay, so from E2, any information else? SU is a perpendicular bisector of RT. So okay, we going to the area of the triangle first. So basically from B we want to get the area of the triangle. So the area of the triangle basic formula we're using as 1 over 2 base times height. So from here we got base RT times height SU. So 1 over 2 base times height. This is the formula of area triangle. Okay, so SU is equal to third RS square minus RU square. So this is 90 degree because of perpendicular bisector. So SU is equal to RS square minus RU square. This is theorem Pythagoras. Okay, you want to find SU. Okay, so RU is equal to half RT. Since it is a perpendicular bisector, so RU is equal to half RT. Okay, so SU, from this formula, SU is equal to RS square minus half RT. So since RU equal to half RT, so substitute in here, so we get this 1 over 2 RT square. So third RS square minus 1 over 2 RS square. So why we use this? From here, from A1, we know RT is equal to RS equal to ST, so we can substitute RT with RS because it have the same length. So since it's in the same form, we can simplify it into 3 over 4 RS squared. So we get this. And then by simplifying it again, this third, we get third 3 RS over 2. So third 4 become 2, RS become RS. So area of triangle is equal to 1 over 2. So substitute back here. 1 over 2 RT is equal to RS times SU. This is SU, right? This is SU. This is what you got from SU. So substitute everything in the formula of 1 over 2 base times height. So you got 3 over 4. Simplify this statement. So you got 3 RS squared over 4, same as your B1. So your proof is complete here back to B1. So we got E6 same as B1. So what is the condensed proof? So you can read it here. So from the hypothesis, since RST is an equilateral triangle, RT equal to RS equal to ST, by using formula of area of triangle, area RST is equal to 1 over 2 RT SU, RT times SU. Line SU is a perpendicular bisector of RT, and by using the theorem Pythagoras, here theorem Pythagoras, SU is equal to third RS square minus RU square. RU is half of RT. RU is half of RT. By substitute RU equal to 1 over 2 RT and RT equal to RS, in SU we get this. And substitute SU in the area of the triangle formula, we get 1 over 2. And then by simplifying, we get the conclusion of the area of the triangle. Okay. So that's all for forward-backward method. You can do some exercise that I have been given in the activity, and you can try to prove yourself some question that you get from your lecturer. And if you have any information or any question, you can contact me at my email here. So thank you. Assalamualaikum and have a nice day.